We are not talking about one force. Okay. If only one force is acting, then you can write down F is the resultant force. But more than one force is acting, then you have to find out the resultant of vectors. Okay, na? Resultant of vectors you have to find out, which is F1 bar plus F2 bar plus F3 bar. That is the resultant. Like that, suppose 10 forces are there. You have to add vectorially all the 10 forces. 10 forces you have to add. Okay. Sorry. So the rate of all the 10 forces is equal to dp bar by dt. The rate of change of linear momentum. The rate of change of linear momentum is called type of net external force acting on the body. Okay. dp bar which m into v bar and right. Yes, I wrote. It's a derivative part now. So that's the derivatives we discussed. I told you, everybody has to learn the derivatives. If you don't have, good knowledge in the mathematics, you will have trouble in physics, no doubt. So d by dt of m into v bar. d by dt of p bar plus m into v bar. And if object mass is constant, see, I wrote the condition of object mass is constant. That means mass can be variable also. Mass of the system can be variable. Mass of the object can be variable. And mass vary out. Okay. So, for example, I told water tanker. As water tanker moves on the road, suppose the valve is open, then entire water goes off. Okay. Water slowly goes off. Then what happens to the mass of the tanker? Mass of the tanker keep on decreasing. Okay. So if I talk about only tanker, forces acting on the tanker, then mass of the tanker is not constant. Mass of the tanker is variable. Okay. So other textbook example for variable mass. Textbook example for variable mass is rocket propulsion. As the rocket goes on, okay, as the rocket goes up, its fuel keep on burning. Usually rocket is something like an 80% of, more than 80% of fuel, and maybe around 15% is only components. Like suppose rocket is carrying the satellite. So I don't know how many of you seen the rocket structure. So top of the rocket only will have the satellite, and remaining entire all the rocket. Okay. So all the three stages, so usually 2 or 3 stages will be the rocket. So that will be filled with the fuel. So more than 80% of the rocket is fuel. Okay. So as the rocket goes up, what happens to fuel? Fuel burns out. Then what is the mass of the rocket? Keep on decreasing. Mass of the rocket is keep on decreasing. Then in that case also mass of the object is not constant. It's variable. So that's why I wrote the condition of mass of the object is constant. As I wrote the condition mass of the object is constant, you can take the mass out of derivative and you can write down dv bar by dt. dv bar by dt we know in kinematics we have done already. Rate of change of velocity is acceleration. So net force is equal to mass into acceleration. So F net is equal to m into a bar when we can write down when mass of the object is constant. There is a condition for F is equal to m bar or F bar is equal to m into a bar. The condition is mass of the object is constant. Okay, if mass is variable, let us say mass is also variable. If mass is variable, then m is also has to be derivative. M into v bar. It's something like a u into v method. U into v. Okay. U and v method. Okay. So u into derivative of v plus v into derivative of v. So same logic applies. M into dv bar by dt plus dm by dt into v bar. The net force I can write on m into a bar plus dm by dt into v bar. Okay, no? So this is the one thing you need to understand in the neutral lasso motion. In neutral lasso motion, F net is equal to m into a bar when mass is constant. If mass is variable, net force we can write on m into a bar plus dm by dt into v bar. The dm by dt into v bar we call it as thrust force also sometimes. That I tell you later, not now. Okay. In the rocket case, we call it as it's a thrust force. Okay, no? Next, third law. So third law is very famous, like action and reaction pair. Okay, every action has its equal and opposite reaction. Suppose if you are applying the force on the wall, then wall will force, wall also will apply the force on you. Okay, you are applying the force on the wall, that is action. Wall will apply the force on you, that is the reaction. Reaction will act on you, and action is acting on wall. Okay, action reaction forces will act on two different objects. Okay, on the same object, equal and opposite forces are acting. On the same object, equal and opposite forces are acting. Cancel. Okay, now equal and opposite forces acting on the same object, then they will cancel out. What is the example? Not forces, I have given example with velocities. In the riverboat case, VRG is equal to VBR sin theta. Which case it is? Zero drift. Zero drift case. Okay, if you want, you can open notebook and check. VRG in one direction on the boat, VBR sin theta on other direction leftward on the boat. So both VBR sin theta and VRG, both velocities are there for boat only. If they are equal, they will cancel. Then boat does not go rightward or leftward, it will go straight because of VBR cos theta. So like that, whenever velocities are anything like forces, equal and opposite vectors, same object, they have to act on the same object, not like different objects. Okay, so equal and opposite forces are acting on the same object, then they will cancel out. Equal and opposite force only, but they are not acting on same object, they are acting on different objects, then they won't cancel out, they will move. Because of these forces, they will move also. Okay. Understood? So that's why I've given one example. As you're keeping the block on the table, then block will apply some force on the table. That we take it as what? Action. Then table will apply the force on the block, that we call it as reaction. So reaction is acting on brake, reaction is acting on table. Okay, no? So that's why I've given one note. What is the note I have given? I've given that action and reaction always act on different objects. Okay, they don't act on the same object. They will act on different objects because this is action reaction. No? For action reaction, we should have two objects, two things we require. Okay, just like hero and villain. Okay, villain like put the hero and versus hero. Hero won't become a hero. Hero like put a villain won't be a villain. Something like that. Okay, action reaction. Action is hero, reaction is villain. Like I said. That's why action and reaction is always present, okay, together, but they don't act on single object because one is applying the action, the other one will apply the reaction. Simple thing ఏంటంటే మీరు మీ ఫ్రెండ్ కొట్టారనుకోండి, మీ ఫ్రెండ్ మిమ్మల్ని కొట్టారు. ఇప్పుడు ఒకడే దెబ్బలు తింటాడా, ఇద్దరు దెబ్బలు తింటారా? ఒకడే దెబ్బలు తింది కదా, ఒక్కడే దెబ్బలు తింటే క్యాన్సిల్ అవుతుంది. ఇద్దరు దెబ్బలు తింటారు, యాక్షన్ ఒకరి మీద ఉంటే రియాక్షన్ ఇంకోటి మీద ఉంటుంది. So both will get hurt. So that's why action reaction will act on both objects, not on single object. So try to understand that. That's why they don't cancel each other. So as we are talking about total laws of motion, first of all, we have to know about forces. Okay, without knowledge of forces, we cannot study anything in the total laws of motion. So that's why I started forces. The basic forces of physics. Okay, so we have different type of forces. The first type of force we are going to see is what? Gravitational force, which is earth attraction. Gravitational force is nothing but earth attraction. It is always attractive force towards the earth, so it will act vertically downward. Okay, no? So now I'm saying that vertically downward, but as we move forward, the things will change. Okay, na? As you're getting the maturity in the subject, so things will change. And after some time, I say that the force will act, gravitational force will act towards the center of the earth. Okay. So right now, what you have to remember is you have to remember like it is always acting vertically downward towards the ground. It will act. So that's why you keep the object anyway. You keep the object on the table, you keep the object on the inclined plane, you keep the object inside any pipe, you keep the object somewhere else. How the gravitational force will act? Vertically downward. It always acts vertically downward. Okay. So whenever object is there, then you can draw one force mg. Mg you can draw, which is vertically downward. Next force is normal force. So when normal force will act, whenever two bodies in contact. Okay. Normal force will act whenever two bodies in contact, and this will act perpendicular to the surface and away from it. Normal force always act perpendicular to surface and away from it. So this is called as one component of contact force. Here we are dealing with all smooth surfaces. Okay, surface is smooth. So surface is smooth means no friction, no roughness, no roughness or no friction. So, but unfortunately, we have to discuss this roughness or friction after this neutral laws of motion. Okay, so that's why you just remember like a smooth surface. Whenever object is kept on smooth surface, then normal force will act because of contact. To contact, normal force will act. That normal force will be how the normal force will act? Perpendicular to the contact surface and away from the object or away from the surface. See, that's why I drawn away. Arrow is away from the surface. So this is the normal action acting on the ground, and this is the normal action acting on the block. See, most of the times we don't take the forces acting on the ground because ground does not move. What we are interested in only objects. We are interested in only objects. We see the only forces acting on the objects. But on the ground also forces will act. So something like an reaction type, that's why it's called as normal reaction. Normal force we also call it as normal reaction. Okay, this is normal reaction. That is a reaction force acting on the ground. N is the one force acting by the block. Force on the block and upward. So one is action, other one is reaction. Okay. So whenever there is a contact, definitely there is a contact force. How that contact force is perpendicular to the contact surface. Nikhil, what do you want in the second law? Already I explained second law, Nikhil. Everything I'm explaining one by one. What you didn't understand, tell me, I'll explain the part. Where is the problem? Relation with the derivatives. No, no. F net is equal dp bar by dt. That is the standard law. P bar means M into V bar. If any constant is there in the derivative, you can take the constant out of it. M outside. Then it's dv bar by dt, which is nothing but a bar. So all we know, dv bar by dt is a bar. In kinematics, we wrote more than 50 times. Okay, if m is variable, if mass is also variable, then m into v bar you can write down. M is variable, v bar is variable. That is it. Then u into v method in the derivative. Derivative two quantities are there. What are the variables? U into v method. U into dv bar by dt plus du by dt into v. M into dv bar by dt plus dm by dt into v bar. Just u into v method, m is constant. I have taken out of it. Nothing I have used. What are we discussed derivatives? So many questions we have done. I think in kinematics. Nikhil, what? Tell me where is the exact problem I'll explain. Nikhil, unmute yourself. You joined later, Nikhil. Already I explained that part. I explained, I went to the other third law. Huh? I think you joined later. Okay. Okay, so you understood the normal action, which is acting perpendicular to the surface. and away from it. Okay, na? So please, you have to remember the things. మీరు అన్ని గుర్తుపెట్టుకోవాలి అయిపోయిందండి. వెక్టర్స్ అయిపోయింది కదా మర్చిపోయి, కైనమాటిక్స్ అయిపోయింది కదా మర్చిపోతే మళ్ళీ అన్ని కొత్తగా ఉంటాయి. ఫిజిక్స్ ఇస్ ద వర్స్ట్ సబ్జెక్ట్ టు లర్న్. మీరు మర్చిపోతే కనుక, ఎందుకంటే ఎవ్రీథింగ్ ఈజ్ ఇంటర్లింక్డ్ హియర్. ప్రతిదీ ఇంటర్లింక్ ఉంటాయి, ప్రతి కాన్సెప్ట్ ఇంటర్లింక్ ఉంటుంది. ఓకే, మీకు వెక్టర్స్ ఎప్పటికీ పోదు. ఇంకా వెక్టర్స్ కంప్లీట్ కూడా కాల. ఓకే, నాకే భయం వేసి డాట్ ప్రొడక్ట్ క్రాస్ ప్రొడక్ట్ చెప్పాలి. ఎందుకంటే డాట్ అండ్ క్రాస్ ఈజ్ మోర్ మ్యాథమెటికల్. అందులో అసలు ఏముండదు ఇమాజినేషన్. ఓకేనా? జస్ట్ టు అండర్స్టాండ్ వర్క్ డన్ అండ్ టాక్ యాక్టింగ్ ఆన్ ద బాడీ, we define cross products, cross and dot products. Okay, సో ఇంకా ప్రొడక్ట్ ఎక్స్ప్లెయిన్ చేయాలి, ఎందుకంటే అప్పటికే మ్యాథమెటికల్ ఎక్కువ అయిపోయింది కదా, అందుకే మ్యాథమెటిక్స్ నాకు కట్ చేసాం. ఇంకా మనం వెక్టర్స్ కూడా కంప్లీట్ చేసుకోవాలా, ఎక్స్ప్లెయిన్ చేయాలి డాట్ అండ్ క్రాస్. Okay, so many people having the problem in subtraction and addition and subtraction and the problem. Okay, so if you don't practice, it will be a tough, no doubt. Okay, for anyone it is tough. Okay, so how the normal reaction is acting? Normal reaction is acting perpendicular to the contact. Okay, so flat surface unit of the perpendicular to contact is okay. If it is a flat surface, perpendicular to contact surface is very easy to draw. Suppose if any curved surface is there, on the curved surface, suppose there is a block, then how to draw the normal reaction? How to draw the normal reaction direction? For that, what you have to do is, you have to draw the tangent first. Tangent at the contact surface. Now draw the perpendicular to the tangent. That will become the normal. This is the normal reaction acting on the block. Similarly, normal reaction will act on the surface also, but usually we don't bother about this. Because surface path will move out. Object move. So that's why we take the forces acting on the object. Okay, na? So for curved surface, first draw the. Okay, I'm writing here. For curved surfaces, first draw the tangent at the contact. Okay, then draw the normal. Normal means perpendicular. Normal perpendicular to tangent line. Okay, so this is the way to identify the normal reaction direction when you are keeping on curved surface. Okay, finished done, understood? Next important thing is force. Tension acting on strings or ropes. Tension acting on strings or ropes. Okay. So let us say I'm taking, this is the ceiling. Okay. There is a rope or string. That is a string or rope. But here we have one assumption. What is the assumption is? mass of the string. See, in the entire most of the cases, whenever they are not specified, we discuss both the things. The assumption first I'm taking is assumption is what? Mass of the rope or string is 0. That means massless strings or rope we are taking into account. So what is the mass of the rope or string is 0. We are not considering any mass of the object, the mass of the rope. But in some questions they'll include the mass of the rope also. So I'll discuss both the things, how to do it. Okay. Now if I take two molecules in the rope or string, so they will be binded with some force or not? Obviously, no material, either solid, liquid, or gas. So there will be some force between the two molecules. So I'm not going into the much details of that. That's enough. Suppose if I'm tying one object of mass in to the rope, so rope is balancing it. This mass is hung to the rope. Mass it is hung. It is at rest. Mass is at rest. That means on the mass, what is the force acting? Mg will act or not? All of it, follow this carefully. On the mass, Mg force will act. Earth will attract with Mg force. And it is not contacting any surface. It is not contact with any surface. Then there is no normal action. But object is at rest. Object is not falling because of Mg. Why? Mg force can catch just into the object in the bottom. Right? It has to fall. But it is not falling. Why? Why it is not falling? You will answer everything and you will ask the doubts. Okay. Nikhil is answering already answered. It's tension force. Tension, very good, very good. Graduation, very good. Exactly. So there will be force. See, somebody will applying the force in upward direction. So who will apply that force is? String will apply the force. The string force only, the force acting on the string. When we are applying the force acting on it. If we apply the force on the string, then string also will apply the force on us. Block is applying the force on the string, then string will apply the force on the block. Okay. So this force acting by the string only is called as what? Tension force. So it's very good. So many people know it. So tension will act throughout the string. Why? Because it's something like a molecule. It's something like in what you know, suppose some number of people are standing in a line. Okay. So under mid school line school or college of school. Suppose last one push so that will go to everybody. Under usually. Last one push. Right? So similarly, you can forces all apply. Who will apply the forces inside the string? The molecules. One molecule will apply the force on the other. That molecule will apply the force on some other. So like that, tension will be there at each and every point of the string. Not only here, at each and every point tension will act. Even on the ceiling also tension will act, which is downward. If I take some other point, then tension will act equal and opposite. Something like this. So like that, at each and every point tension will act. Why? Because everywhere molecules will present. Everywhere molecules will present. So the force between the molecules only we call it as simply tension. So it will be acting on each and every molecule. It will translate. Suppose this is the string. Let us say this is the string. Now I'm pulling the string on both ends with F force. Okay, we are pulling with F force on both sides. Then what will happen? String is not extensible. It's not what is that extensible string? It's not like a rubber guard. Okay, this is inextensible strings. Inextensible strings means string does not extend. Then tensions will act in this way. TNT, where T value is equal to F. Tension acting in the string is equal to exactly, not like spring. Okay, tension value is equal to applied force on it. Force acting on it usually for time being, but in the deep okay. So tension will act everywhere, each and every point. Suppose if I take one point of the string, then tension is nothing but molecular forces will act equal and opposite. Okay, so tension force is nothing but forces acting in the strings or ropes. So how this tension will act always? Tension always act up obviously along the string. So string along the line adjust obviously because we already what is that understood that tension force is because of molecule forces, force between the molecules. Tension always act along the string and away from the objects. Tension always acts along the string and away from the objects. Means tension is acting away from the object, something like this. Okay. Clear? Or if understood? Now what we have to do is, I'll give you one thing. Suppose there are two strings. Now I'm taking one block of mass in is hanging by two strings, something like this. Then what are the direction of tension forces? All of you try for this project. Again, masses are, mass of the ropes are 0. Ropes are massless or strings are massless. Just draw them. No need to answer. Just draw them first. You draw them, I also draw and verify whether it is coinciding or not. Any mistake you are doing. Two strings are adapted, two different tensions you can take. You can take like T1, T. Okay, so you have to follow one statement, that is what? Tension always act along the string and away from the objects. Okay, draw. I think you have to write down also. Write down and draw. Where don't first of all leave all these things, just draw the tensions. Please follow me. Okay, మీరు అన్నసరిగా కొన్ని ఐడియాస్ ఫ్రేమ్ చేసుకున్నాం అనుకోండి, మళ్ళీ ఐడియాని బయట తీసి వేరే ఐడియాని కొత్త లోపల పెట్టాలి. దట్ ఈస్ వెరీ ప్రాబ్లం. Okay, while listening to the physics, just blankly can listen. Constant variable value ఏంటి అనేది మనకు అవుతుంది. Will have time. Okay, చాలా టైం ఉంది, మంచిగా నేర్చుకోవచ్చు. మీరు చెప్పింది ఫాలో అయితే చాలు. ఓకే, మీరు మధ్యలో పిచ్చిడి చేయకుండా ఉంటే చాలు. మీరు ఎప్పుడైతే పిచ్చిడి చేస్తారో మొత్తం మీ ఐడియాస్ మారుతాయి. అప్పుడు సాల్వింగ్ క్వశ్చన్స్ విల్ హ్యావ్ ఎ ప్రాబ్లం. ఓకే, సో హౌ టు డ్రా ద టెన్షన్స్? లైక్ టూ స్ట్రింగ్స్ ఉన్నాయి కదా, టూ టెన్షన్స్ అనుకుంది. లెట్ us see the first string, the second string అనుకుంటే ఇందులో టెన్షన్ T1 ఉంటుంది. ఎలా చేస్తుంది? Along the string and away from the object. Along the string and away from the object. అంటే మీరు arrow ఎట్ పెట్టాలి, ఆబ్జెక్ట్ నుంచి అవే పెట్టాలి. దట్ ఈస్ ద డైరెక్షన్ ఆఫ్ టెన్షన్. So entire string tension will be same. Okay, if you want, you can write down one more thing. Throughout the string, tension will be same. Okay, for what I'm writing? For massless strings. Strings ki mass ledanukonde. If mass of the string is 0, then everywhere tension value is same. And if you got tension acting on the ceiling also, what is the tension acting? T1. Not only that, you take any point in the string, tension will be T1 only. At any point of the string also, tension will be T1. Similarly, what is the tension acting away from the object along the string? So T2. And here also, what is the tension acting is T2. Understood that? So these are the tension forces. Hope all of you drawn these tension forces. In the drawing, sir? Any doubt in this? See, everybody has to know the drawing the forces. If you don't know drawing the forces, then forget about the neutral laws of motion. So అందుకే మీకు 3 forces కంపల్సరీ తెలియాలి. ఒకటి వెయిట్, రెండోది ఏంటి నార్మల్ రియాక్షన్, థర్డ్ వన్ ఇస్ వాట్ టెన్షన్ యాక్టింగ్ ఇన్ ద స్ట్రింగ్. You have to know all these forces. Okay, finished done? So now, so we have seen the 3 fundamental forces. One is weight. Next one is what? Next one is normal reaction or normal force. Okay, I'm writing as normal reaction. The third one is tension force. Along with that, there are so many forces. Viscous force is there. Gravitation force means weight on, but that form will change. Frictional force is there. Okay, resistance forces are there. Buoyancy force is there. Legally saying nuclear forces are there. Electrostatic forces are there. She will answer everything. Okay. Electrostatics, nuclear. He is answering almost 12th standard also. Okay. So then these are the some forces. Like as we are going in, as our journey goes on, so we will come to know the different forces. Okay. Yeah. So, but we are working right now with the 3 forces, and we are trying to get how the object will move. Okay. So here these are the 3 forces. First of all, to analyze the forces, we require one thing is called as free body diagram. Okay. What is the other one is free body diagram. So simply we call it as FBD. It's something like an analyzing an object, analyzing the forces acting on the object. Okay. So what is the meaning of free body diagram? Drawing all forces acting on the object. Drawing all force acting on the object is called as what? Free body diagram. So what is the meaning of What is the meaning of drawing all forces acting on the object? Let us see. So example 1. Suppose there is a ground. On the ground, I kept a block of mass. On the ground, I kept a object of mass. Okay. Now I want to draw the free body diagram of the object. Not ground. What is our subject? Our subject is only object. Object is moving. Okay. So all of you draw the forces acting on the object. Please saying two forces. You can draw it first. You can answer first. You draw, please. Don't need to answer to me. First, to draw them. నాకు ఆన్సర్ చేయాల్సింది క్వశ్చన్స్ ఆన్సర్ చేయాలి, వీటి కాదు, ప్రాబ్లమ్స్ ఆన్సర్ చేయాలి. Now what is the free body diagram, FBD, of object? Free body diagram object means you draw the only object, and draw the force acting on it. How the mg will act vertically downward, and contact force is there, no contact is there. Then what is the other force is acting? Perpendicular to contact, normal force or normal reaction will act, and which is away from it. See, this is the normal reaction acting on the block. I'm not drawing the normal reaction acting on the ground. I'm drawing the normal reaction acting on the block one. Understood? Clear? So this is called as free body diagram. Right side, whatever is there, drawing the block and drawing the forces is called as free body diagram. Okay, clear? Everybody ready? So next one. So on the inclined plane of inclination theta, there is a block of mass and is kept. Now draw the free body diagram for this object. So now we have to know how to draw the free body diagrams of different situations. Okay. Okay, it's not three forces. Still it is two forces only. Are there drawers now? Nikhil, please don't overthink. Just follow me. I told you already, we are dealing with all smooth surfaces. We are not taking the friction. Do you know friction? You will tell everything. Okay, your choice. Okay, you take the friction also. Remaining papers do with the smooth surface. Okay, so please don't include the friction until the next chapter. Then there will be no confusion. You will happily learn everything one by one, step by step. Okay. If you are mixing just now only I told to variation also. If you are mixing all ideas, you know some things. Physics kada common sense. ఏదో తెలుస్తూనే ఉంటుంది. దాన్ని మిక్స్ చేసామా మొత్తం కిచిడి అవుతుంది. Ultimately you will lose the ideas. Okay. Yeah. So on the inclined plane, there is a block of mass M. Then mg will act vertically downward. And how the normal action acts? See here again, what is our subject? What is our target? Our target is only block. So we have to draw the forces acting on the block only. So the normal reaction acting on the block is something like this. This is the normal reaction. Okay. So nickel friction upward draw chesa downward draw chesa. Friction ela draw chesa nickel. Friction kuda తీసుకున్నారు అది. What is the direction of the friction? Opposite to what? Opposite to block. Block allowed. Opposite in the direction. Block is not the direction. Okay, so please leave it. I'm why upward? It can be downward also. It can be downward, it can be upward. Okay, so that's why please don't go for all these things. I will give you clarity. I will explain all the things. Whatever I'm explaining, please follow that. Okay, otherwise you can go upward also. It can be upward, it can be downward. Both the cases are there. Okay. Next example. So previous diagram. I have given one diagram something like this. So the free body diagram. Nikhil, you are going for the next chapter. That's why I cut the discussion, but you are increasing my discussion. You directly nodal motion relation next chapter will turn. Friction direction, the friction does not oppose the motion. Friction opposes motion just move down the bar. Friction can support the motion also. Okay, so that's what I'm saying. Please follow me. You don't have certain knowledge. Okay, so don't unnecessarily fall into this type of trap. Okay, so first we learn about nodal motion. Then we have a chapter friction. Entire chapter is there. We will discuss there all the situations, all the things I explained. Okay, na? My school studies F physical ME, but I didn't tell you F physical ME. In F net bar is equal to A bar and mass constant, mass variable, two situations. Okay, na? My 10th standard physics వేరే ఉంటుంది, ఇక్కడ ఇంకా వేరే ఉంటుంది. అందులో మీరు నీట్ వరకే ఉన్నారు. అది జేఈ వరకు ఉంటే ఇంకా బోల్డెన్ కేసు చెప్పాలి. Okay, there are a lot of cases in JEE. So late kabute I'm restricting myself to some level. Okay, please follow these things. If you are unnecessarily going into the other things, you will only confuse yourself. Okay, Brahma. Then if I take object, let us take this angle is alpha. This angle is beta. See, I'm slowly preparing for you to the questions. So there is a block of mass in free body diagram. Energy will act vertically downward. So for one string, tension will act T1 at what angle? At an angle alpha. The other string T2 at an angle beta. Okay, T1, T2, and G will be the three forces acting. T1, T2, T3 will be the three forces acting on the object. Okay, completed the. So let us go with a little complicated now. Now, imagine this is a one inclined plane of inclination theta. Okay. So there is a sphere which is held at rest between wall and inclined plane. This is the wall, like I said. Okay. Let us say this is the wall. Now draw the forces. Draw the force in the diagram itself only. Mali where 3-point diagram draw here. You can draw itself only. Mass of the sphere is m. Okay. Draw carefully. No? So in the nodal laws of motion, you have to learn one technique, that is what? Identifying all the forces. Identifying all the forces active in the object. So that is the technique. If you can learn technique, then we will see how to deal with the forces. Step by step we are going, so that you will be in a position to solve the questions. Okay, down. See, first of all, the weight mg will act downward. See, actually, we have to draw the other diagram, but for now we are not drawing the other diagram. Okay, so we are drawing on the all forces on the diagram itself only. Okay, na? Actually, మనం sphere తీసుకొని we have to take a sphere separately and we have to draw the forces. So then this is one contact. See once, this is the contact. So the sphere is in contact with the inclined plane. So as the sphere is in contact with the inclined plane, every contact will have normal reaction. Remember that. Then here, the normal reaction that which I am taking as N1, see the normal reaction to the sphere always should pass through center. Remember this logic. Why? Because if I am taking a sphere, okay, it's now curved surface. So what is the normal reaction means? Normal reaction acting at a point means you have to draw a tangent. I think you remember this. You have to draw a tangent. You have to draw it normal to it. Then it will pass through center. For spheres, if you want, you can make a note. For spheres and cylinders, not only sphere, for cylinder also. Cylinders. For spheres and cylinders, normal reaction should pass through center. Okay. So actually I wrote like normal reaction should pass through center, but I have to write like normal reaction will act radially. Okay. What the other statement is? Normal reaction acts radially. Radial means along the radius. Along the radius means it will pass to center only. No? Now there is one more contact here. For the given question, there is one more contact. So then how the normal direction is? Second normal direction is there will be some other normal direction which also passes through center. So every normal direction acting on the sphere should pass through center only. Okay. Because already I told you same thing. Radial means along the radius. Okay. Then N1 is one force, N2 is other force, Mg is third force. Total how many forces are acting on the sphere? 3 forces are acting on the sphere. Completed that? Very good. Next example. See, all these are questions actually. First time I am teaching how to draw the forces. Then we did how to go for resultant of force. Okay. So then we can discuss the motion of the object. Like that, step by step I'm going. So now there is a ground. Let us say there is a ground. There are 3 cylinders. 1, 2. Okay. There is a third one also, like something like this. There are 3 cylinders. One is kept on other. Okay. Now? 3 cylinders are placed as shown in the figure. Okay, you are able to see the cross section. This is ground. This is the first, second, and third. Okay, each mass is n. Let us say. Then draw the forces or draw the free body diagram of second sphere. Sorry, second cylinder. Cylinder. No, this is. Draw the free body diagram of second cylinder. So now I want only second cylinder. Nikhil, first you are drawing your notebook. First you are drawing the notebook. Okay? Then you can answer to me. No problem. First you are drawing the notebook. Always you try yourself first. In your notebook you draw all the things. Then you can answer to it. Okay, draw. So you can draw separate cylinder and you can draw the forces. That is one idea. Or in the same diagram only you can draw them also. Your choice. Anyway, you can do it. So if you see in the diagram, second and first sphere in contact, even third and second sphere also in contact, even ground and second sphere also in contact. Then how many contacts are there? Total contacts will be three. Three contacts will be there. And then what is the free body diagram you can draw? Of second cylinder is, suppose if I'm taking this is one contact ground. So then we have, I'll take N1 and this is another contact perpendicular, this should be N2. See, all should pass through center. Okay, na? Third one is somewhere here. So then this will be N3. Okay, na? All will pass through, all normal direction will pass through normal direction, center, all normal directions, and MG will act vertically downward. MG is acting vertically downward. Okay. So total, how many forces are acting? 4 forces are acting. 3 normals, 1 MG. Okay, all of you got this? Okay, so let us go to the next part. All of you draw now? Anybody drawing? I think all of you drawn, right? So next example, example 6. Suppose there are 2 spheres. Okay. Let's take one more space in this. One is in contact with the other. So both are kept inside a inside a glass, let us say. 2 goalies. I think all of you know goalies, right? 2 goalies are kept inside a vessel. All of you understood the situation? 2 goalies, 2 spheres are kept inside a vessel. Now, first and second, draw the free body diagram of both. Both spheres. First one free body diagram draw, and even second one also free body diagram not to draw. First and second both. Then got to button. Okay, very good. Vishnu, correct. All normal action pass to center. Give it downward. Okay. So let us see the first one. I'm drawing in this diagram itself. First of all, this is one point that I'm taking point two, and this is one contact. So four. What is it? P1. Then N3 will act because second sphere is applying the force on first sphere N3. Then first sphere also will apply the same force N3. Voice is not clear. Huh? Okay. So, able to hear me? Sorry. You're able to hear me or not? Okay. So, see, since applying some force on first sphere, bottom is unable to hear me. So, how many of you have clarity now? Audio is clear. Voice is not clear. Ultra is clear. Some people are saying audio is not clear. Some people are saying it's perfect. Voice is clear. Okay. See, what I'm saying is two. Second sphere is applying some force on first. This first also will apply the same force on the second. There is not saying voice is not clear. Adil, how voice is clear? Audio is clear? Adil, audio is clear or not? Are you able to hear me? Okay. Adil is saying good. So maybe some network issue. Maybe internet fluctuation, that is okay. So okay, now N3 and N3 all of you understood? It should be same. Remaining may differ. Then this will be same. Action reaction phase. Okay, Adil. So I changed my Wi-Fi setting, Wi-Fi to other. So hope your voice is clear now. Okay, everyone able to hear me? Clearer? Okay. So all of you understood why I have taken N3 and N3 same? Okay. So yeah, I switch it from one Wi-Fi to other Wi-Fi. See, N3 and N3 is same or not? All of you understood? What, Gautam? What you're asking? We are talking about only forces acting on the spheres.
Sir, good morning, sir.
Good morning, that's better.
Sir, ఇక్కడ N2 force first మనం కదా sir.
N2?
N2 force. N2 force, sir.
Force? Even N2 force.
Hello, sir.
Even N2 force?
ఇప్పుడు ఫస్ట్ స్పియర్ లో మనం N2 ఫోర్స్ తీసుకున్నాం కదా సార్ ఇక్కడ, అంటే దీనికి బౌల్ కాంటాక్ట్ ఉంది కాబట్టి సార్, అంటే మళ్ళీ సెకండ్ స్పియర్ లో తీసుకోవాలి కదా సార్?
సెకండ్ స్పియర్ ఎందుకు తీసుకోవాలి?
అంటే ఈ బౌల్ కి కాంటాక్ట్ ఉంది కదా సార్?
బౌల్ కాంటాక్ట్ ఉంది
అంటే అప్పుడు NT ఫోర్స్ కూడా యాక్ట్ అవుతుంది కదా సార్ దీంట్లో సెకండ్ స్పియర్ సార్?
సెకండ్ స్పియర్ అంటే ఎందుకు యాక్ట్ అవుతుందా? N2 ఫోర్స్ ఏమో ఫస్ట్ స్పియర్ మీద యాక్ట్ అయితే N2 ఫోర్స్ బౌల్ మీద యాక్ట్ అవుతుంది అంతే కదా?
ఓకే ఓకే సార్. ఓకే సార్. ఓకే సార్.
సో N2 మీద బౌల్ అప్లై చేస్తే బౌల్ మీద N2 అప్లై స్పియర్ అప్లై చేస్తుంది. కాకపోతే బౌల్ మీద అప్లై చేసే ఫోర్సెస్ అవసరం లేదు. We don't require the forces acting on the ball. We require only force acting on the spheres. Already I told, no? We always concentrate on the objects. Ground meda, balls meda, usual ga avasam ledu. Question adite appudu teesukovalsinde. But every force has its own action and reaction force. Okay? So if second sphere is applying the force on first also will apply the force on the second. Silila did complete. Nikhil, action and reaction pair. Second is applying the force on the first, then first also will apply the force on the second. Sphere 1 is applying the force on the ball, then ball will apply the force acting on the sphere 1. But we are not taking the right, we are not drawing the forces acting on the ball. Okay. So then one more force will act, that is here N4. N4 will be acting on the second sphere by the ball. On the ball also N4 will act. On the ball also N2 will act. On the ball also N1 will act. But we are not taking those forces. So this is the N1 on the ball. This is the N4 on the ball. Nikhil, what to answer? I'm unable to understand. Nikhil is asking, action and reaction pair are always equal, sir. So he will talk about friction, he will talk about all the things, electrostatic forces. But he does not follow the things what I'm saying. Every action, see the statement Nikhil wants. Every action has its equal and opposite reaction. What does it mean? It means they are equal in magnitude, opposite in direction. Nikhil, please follow. నువ్వు తలకాయలో అన్ని ఏం చదువుతున్నావు తెలియదు కానీ మొత్తం అంతా చెత్తంగా పెట్టుకుంటున్నావు. దానివల్ల అసలు నువ్వు ఫాలో అవ్వట్లేదు. I feel. I don't know whether it is correct or not. Okay, please follow me. So I'm discussing all one by one. You will get it. You will understand everything. But already preoccupied undanukondi మీ brain. It's very tough. అందరికీ చెప్తాను. Physics ఏంటంటే preoccupied undanukondi, it will be tough to understand. Okay. అందరికి అర్థమైందా ఎలా డ్రా చేయాలి ఫోర్సెస్? All of you understood how to draw the forces? Now I am going for some other examples. Now this is the ground, let us say. On the ground, I kept one object of mass m1, one block of mass m1, other block of mass m2. So we are applying the F is the force. We are applying the F force on the blocks. Now draw the forces on M1 and M2. Draw the FBD diagram of M1 and M2. Draw the forces on M1 and M2. Okay, positioning, very good. In external force for each, F is the external force acting from the outside. Draw the all forces acting on M1 and M2. Free body diagram means we have to draw all forces acting on blocks. Okay. Finish the all of it, right? Are it finished the? See, suppose if I take only M1 object, okay. So F is the one force acting which we are applying, let us say. Then M1G will act downward direction, gravity, and the normal reaction will act upward. N1. N1 will act upward, and there is a contact between M1 and M2. So here also normal reaction will act. But that normal reaction we are writing as contact force. So how the contact force will act? M2 will apply the M1. So this will be the contact force. So this will be the contact force acting between M1 and M2. Contact force, normal force, you can write on normal reaction, you can call it as any way. Ultimately, the force will act perpendicular to contact. So F is the force acting. Okay, no? Then M1 will apply the force on M2 will be something like this. Action reaction pair. M1 will apply the force on M2. M2 will apply the force on M1. Okay. So again, ground will apply the force on M1. M1 will apply the force on ground, but we are not taking the force acting on the ground because it's a free body diagram of M1. That means we have to take the only forces acting on M1. Sir, post evara? Sir, post evara naku? Gautam, what you are doing to understand? Gautam, contact force and
Yes.
normal force కదా?
Sir,
Gautam, contact and normal force. Contact ఇప్పుడు నువ్వు M1 M2 పుష్ చేయాలి కదా?
yes, sir.
M1 M2 మీద ఫోర్స్ అప్లై చేయాలి కదా.
ఎస్ సార్.
అప్పుడు M2 M1 మీద ఫోర్స్ అప్లై చేస్తుంది కదా.
ఎస్ సార్.
That only I am writing as contact. Then
సార్ యువర్ వాయిస్ ఆర్ నాట్ క్లియర్ సార్.
చేంజ్ నేమ్ చేంజ్ అయింది అంతే. నీ Gautam, what I am saying is, suppose you are pushing the M1, then M1 ఏం చేస్తుంది, M2 push చేస్తుంది. అంటే M1 M2 మీద ఫోర్స్ అప్లై చేయాలి. Then M2 will apply the force on the M1. Action reaction period. Okay. So on M2 now F is the force acting. M2 will like downward gravity, and normal reaction M2 will like upward. Okay. So M2G and N2 will like upward. So total how many forces are acting on M2? 3 forces. How many forces are acting on M1? 4 forces. Okay. So F we call it as what? F we call it as contact force between M1 and M2. Okay. So that is the forces. Once you know the forces, it is easy to go with the force. Very easy. Everybody has now identifying the forces. Forces identified the forces are all. Okay. Okay, other field on. Okay, completed. So all of you go through this, please revise. మీరు ప్రతిదీ వీలైతే చూడకుండా రాయడానికి ట్రై చేయండి నోట్బుక్ లో ఉన్నది. పర్టికులర్ గా F net is equal to M into A bar, F net is equal to M into A bar dm by dt bar. Mass variable, mass constant, 2 pages. మీరు చూడకుండా derivation రాయండి. If you can write down the notebook again, okay, practice చేస్తే then you will follow things properly. So easy కూడా ఉంటుంది. ఫాలో అవడం ఈజీ ఉంటుంది. ఓకేనా, అన్ని అర్థం అవుతాయి అండ్ క్వశ్చన్స్ కూడా సాల్వ్ అవుతాయి. లేదు నేను వినేసి కూర్చుంటా, ఫిజిక్స్ దానంతా అదే వస్తుంది, ఏదో ఫిజిక్స్ అవాహయామి అని కూర్చుంటే మాత్రం ఫిజిక్స్ రాదు. ప్రాక్టీస్ చేయాలి. ఓకే, సో బాయ్ ఎవరీవన్, విల్ మీట్ టుమారో. ఓకే.